Imagine a huge apple tree with apples in different sizes hanging on its branches. As the apples go higher, it gets harder to reach them. So we want the biggest and most beautiful apples on the lower branches. The effort needed to pick the apples will increase if they are further away from the ground. Coding a text has almost the same logic. In a greedy approach, we want to code the letters, which we need the most, with using less bits. And in this video, we will be using Huffman coding for this. Now, let's see an example. We want to code this statement. It has 6 A's, 1 D, 4 N's, 2 L's, 2 I's, 1 Y, 1 B, and 1 R. We first write the frequencies of each letter and start our greedy process. But before that, if we code these letters without using any particular algorithm, we need to use 3 bits for each letter because we have 8 different letters, and with using 3 bits we can make 8 different combinations. Our statement has 18 characters in total, and 18 times 3 gives us 54 bits to code this. Let's apply Huffman coding this time. It will make it easier if we write the frequencies in an ascending order. We will continue with merging the smallest numbers at each step, and at the end we will have a binary tree structure. In the first step, we take D and Y, merge them and take the sum of their frequencies, which makes 2. The next step will be taking B and R, forming again 2. We merge L and I next. Now we are taking these two 2's and join them. Then the 2 4's here. Now the smallest pair of numbers left is 4 and 6. So we merge N and A, which gives us 10. As the last step, we join 8 and 10 and finish our tree. To understand the next step better, we draw it again like this. Here we name each left edge 0 and each right edge 1. Now we can code our letters. It will follow like this. As it is obvious, A and N, which have the highest frequencies, are coded with 2 bits, while R, B, Y, and D, which have frequencies of only 1, are coded with 4 bits. And here is our message after applying Huffman coding. We multiply the frequencies with the bit lengths of each letter. This is 48 bits in total, and it is the optimum number of bits to code this statement.